Hello everyone. This week I've been working on the project for anomaly detection for stock market and financial market data. The main goal of this project is to develop a AI-powered project that where we can detect financial market anomalies and generate investment strategies. Here we are using the Bloomberg financial data, several machine learning models and graph-based deep learning models, and we've built an end-to-end system for analyzing market trends and optimizing investment decisions. So let's jump in. The data for this project comes from Bloomberg, as mentioned, and which is one of the most trusted sources for financial market information. Initially, we start by pre-processing this data, uh, basically renaming unnamed columns, ensuring that all the data is cleaned, as well as ensuring that there is no missing data. The Y column here represents the anomalies, which basically is a Boolean category. Once we have pre-processed our data, we start with working with the machine learning models. We start with the simple machine learning models such as logistic regression, and then perform random forest with mode. Here initially we notice that there is class imbalance. So we apply the smooth technique in order to handle class imbalance and improve the overall recall score. But before that, we also perform PC analysis in order to find the 10 most important features, where we notice that the VEX feature is the most important feature. And based on that, we also apply grid search in order to find a good random forest based model. And we also implement so for the random forest mode model, we get a recall of around 93 and 93 for the zero label and 78 for the one label, so which is quite good. And in addition to this, we also train a MLP classifier, and which is not performing as well as the uh, class uh, class balanced random forest smooth model. And one unique thing that we are developing here is a graph-based deep learning approach in order to understand the information flow and in order to incorporate the time series information. So, moving on to the GIN architecture. Graph isomorphism networks or GINs are particularly effective in scenarios where the relationship between features matters, as well as when it is a time series based information, as they model the data as a graph rather than just as a table. So in our case, we represented the financial data set as a graph where the node represents the currencies or market indicators, and edges represent the time series information, as well as capture the correlations and dependencies between the different nodes. Once we have done that, this allows the graph isomorphism network to detect subtle patterns and interdependencies that traditional models might miss. And its ability to generalize these relationships has helped outperform it uh, from the other models that we have trained for identifying anomalies. And it had a very high testing accuracy of nearly 87%. Once we have done that, we also do some TCNE in order to understand how the data is distributed for among the different graphs that we have distributed. And lastly, we leverage large language models using the Grok API, and we use the historical data as well as the model predictions so that the LLM can generate tailored investment strategies. And we develop a chat-based system where you can ask questions based on the information from the historical data as well as from the question provided from our model predictions. So here's a representation of the UI, and you can just click on generate strategy in order for the LLM to use the predictions as well as the historical data to provide suggestions on how to trade through the anomalous trends during the financial market anomalies or crashes. And then you can also ask it a question where it'll give you information on the currencies that were most affected due to the anomalies from last year. So based on our GIN model, it predicts that the peso, Turkish lira, Venezuelan bolivar, British pound, and Brazilian real are the most affected. So this is based on the time series information as well as also combined with some other the previous models predictions. So that's it for this project. Thank you.